So probably one of the first things that engineers new to Junos notice when they're coming from the Cisco world is that in configuration mode, things are a little bit different. You know, in iOS, it's very true that whenever we make changes in live production, we need to be careful, particularly because every single command enacted in iOS takes instantaneous effect. You go in conf t, you set an IP address, it instantly bang appears on the interface. You shut the interface down, it's gone. You know, every command that is syntactically correct, the minute you hit enter, it's entering production. And that means that with iOS, it's not just important to think about what you're going to do during a maintenance window or configuration of the live network, but particularly in what order you're going to do it. Shutting an interface down before having brought an alternative path up could be disastrous. You could end up cutting yourself off from the box. So like I said, the thing we notice when we go to Junos for the first time from that environment is config mode is very different. You know, we could maybe describe it as a batch configuration mode. Now, what do I mean by that? I mean that in Junos, when you type configuration, what you're really doing at that moment is triggering a copy of the current active running config. So we can imagine here, you know, inside our box or MX router or whatever it is, we have lots of different configuration. And the moment we type configure, we're literally taking a copy of that current active configuration and making a copy of it. So we've taken the active config and made it a candidate configuration. This is a text file held within memory on the box, well, in fact on disk on the box. And in config mode, you're effectively editing that candidate configuration. I mean, obviously the CLI is enforcing syntax, making sure all the commands you give are valid commands and so on. But the important point is, as we make changes, let's say we've got a user A SSH down in here in the box. User A SSH is in, types configure, goes into configuration mode, and then makes some changes. You know, maybe user A does something very simple. Maybe they change the host name of the box. Maybe they add a new user. You know, if they type commit, all of that configuration is going to be checked, or sanity checked, I should say, for some basic kind of conflicting configuration statements that are not allowed from Junos' point of view. And then if that check is good, then what was the candidate configuration will become the active configuration. All right, so this sounds great. I mean, now we don't need to worry so much about what order we do things in. We might make one change, 2, 3 changes. You know, we know that as we make changes on the CLI, all we're actually doing is editing a candidate configuration that has no effect on the current production behavior of the device. Like I said, once we type commit, it becomes active. You know, we don't need to worry about the order and so on. What else was I trying to say? Oh, I remember now. I'm imagining a bad situation that's happened to me more than once. You know, this is a nice story, but what about if we imagine another user? Let's say we've got user B down here. You know, comes along, user B, SSH, connect to the box. At the same time that user A is still in configuration mode, editing that candidate. You know, and now he goes into config mode as well, types configure. You know, he's going to see a warning on screen. It will tell him warning that another user is currently with, or the candidate configuration is currently being edited. But you know, maybe user B is busy, distracted, doesn't read that warning on screen, and starts entering his own commands. So now we have one candidate file with 2 or potentially even more users logged into the box. They've been warned, but maybe they didn't see it, and they're now adding to that same candidate. Let's say that user B types commit when user A is still in the middle of his changes. What's going to happen? If we're lucky, user A is doing something that is only partially configured within the candidate. Maybe he's creating a new BGP peer and it doesn't have the minimum mandatory statements. So when user B types commit, we get an error. The commit fails, and this kind of is a wake-up call to user B. Hey, ooh, this is weird. Somebody else is adding to the same candidate as you. If we're unlucky, it passes the minimum sanity check and we get some partially finished config by user A alongside B's changes all at the same moment pushed to active. That could be disastrous. So for this reason, we actually don't prefer that users, when logging into the box, enter configuration mode with just the straight configure command. We'd rather they use configure private. So it's probably fair to say you should think of that as a best practice. All right, so we already talked about the idea that just entering config mode with the configuration command on its own can have some potential issues. You know, we said that maybe we've got 2 users, both editing the same candidate, that could potentially result in some headaches for us. We said that far better, best practice is to do configure private. So let's see exactly how config private would save us from the situation of two users kind of fighting or conflicting with each other. Let's imagine this, let's say user B down here. User B logs in, types configure private, and we've gone into config mode, so we expect that spawns a candidate configuration. All the changes that user B makes are just simply editing that candidate and having no effect on production until he's ready, until he commits, until our commit check passes, and this becomes the new active configuration. So user B is merrily typing away. Everything is good. And now we imagine that user A logs in at the same time. So user A makes a connection, types configure private, and this spawns a separate private, hence the name, candidate configuration file. All of user A's changes are contained within that particular candidate, and at some point one of them is going to commit first. It doesn't matter who commits first. Let's say that user A commits first. We can imagine if the commit checks pass, then all of his changes from his private candidate are now merged into the active running configuration. Later, could be 2 minutes later, it could be half an hour later, it really doesn't matter. User B is going to come along and run a commit, hopefully pass his commit checks, and have all of his changes merged alongside the user A changes in the same active running configuration. The system handles intelligently for you this merge. What do we need to worry about? Some things we can't fix. If user A changed the host name of this box to foo and typed commit, and user B makes 20 changes in his candidate, but one of those changes is to change the host name to bar or something else, well, when we commit, 19 of his changes get merged in alongside with no effect to what user A has achieved, but that one command that's directly conflicting, user A setting one host name, user B setting another host name, obviously whoever committed last at that moment is going to win. That we can't fix. At some point we need to coordinate the human members of our team, make sure they're not fighting each other on the box. But I think you'll agree this is a lot nicer situation than just hoping the 2 or however many users in our ops team notice a warning if they simply type configure, if they don't use this configure private. There is one very small downside to using configure private. It's really just a minor annoyance. Once you've done configure private as opposed to just configure to change the mode of operation on the box, you can't commit unless you're at the top of the configuration. So if you've jumped around in the config tree, you're buried under OSPF or BGP neighbor config, type commit, you're going to get an irritating warning that tells you, warning, you can't commit in private mode unless you're at the top of the configuration tree. Once it becomes habit, no problem, but the first few times it's slightly annoying. All right, cool.